Hi, welcome to Math for All, where everyone can learn more about math. Today, we will expand our knowledge of functions by learning how to write a function rule of a linear function or a sequence given some points. Our function rules will look like this. Y, or f of x, equals, say, negative 2x plus 6. I have some cool steps to be able to figure out what the function is given some points. So let's show you what's up with these. Our problem looks like this. Write the function rule for this set of data. When x is 1, y is 5, 2, 7, and 3, 9. Let me write out the steps as we move along. Step 1, write y equals. Easy enough. I hope that all the steps are like that. Step 2, find out what the y's are going up by. And for this example, the 5 goes to a 7, and then the 7 goes to a 9, increasing by 2 each time. Step 3, write that number in front of the x to start our equation. We multiply it by x because it goes up by 2 every time that x goes up. We are at y equals 2x, but we're not done yet. We have a puzzle step where we have to figure out if we have to add or subtract anything on the end. So, step 4, pick a point given. I'll choose the 1, 5, and put that into our unfinished equation of y equals 2x. The x is the 1 and the y is the 5. At the end, we will add or subtract a number to make it work. 5 equals 2 times 1 plus or minus what? Since 5 equals 2 plus 3, at the end, I know that I have to have a plus 3 for the final function rule of y equals 2x plus 3. Notice that for any of the points given, this rule will work. If I put in 2 for x, I have 2 times 2 plus 3, which equals 7, and 3 times 2 plus 3 equals 9. Fantastic! We have a winner. Since this may be a brand new concept for you, let's use the steps to find the function rule for another example. When x is 1, y is 3. When x is 2, y equals 8. And when x is 3, y equals 13. We'll investigate this with our new techniques. Step 1, write y equals. Step 2, what are my y's going up by? The 3 went to 8, so 5 was added, and then the 8 went to 13, or up another 5. So, plus 5. Step 3, put that plus 5 in front of x, and we're at y equals 5x. Step 4, and the most tricky part. Take a point. We can use 1, 3, and put that into our y equals 5x, and figure out what we need to add or subtract to make it work. 3 equals 5 times 1 plus or minus what? If I'm at 5, I need to subtract 2 to get to 3. So my final function rule is y equals 5x minus 2. And this will work for any of the points given, as well as the pattern keeps going to infinity. Here's one more example that shows one little twist they can throw at you. What's the function rule of 1, 7, 2, 4, and 3, 1? No need to panic. We have a strategy that will work. First, we write y equals. Next, what are the y's going up by? 7 goes to 4, so it is going down by 3. Same for the next point. Because each term is going down by 3, this time we put negative 3 in front of the x. We have y equals negative 3x. We'll use that point 1, 7 and put in the y and the x. For 7 equals negative 3 times 1 plus or minus some unknown. How much more does negative 3 need to get up to 7? One way to think of it is that I need 3 to just get me to 0, then another 7 from there for a total of 10. So my function rule is y equals negative 3x plus 10. Yippee! Way to expand your knowledge with these function rules. These steps only work if the y's go up by the same amount each time. Later, you will learn to solve these using some linear formulas, but this is a great way to introduce you into function rules. So keep up the awesome job in learning more about math.